Let us now consider equations with coefficients that are linear in the variables x and y. So let us consider the equation a1x plus b1y plus c1 dx plus a2x plus b2y plus c2 dy equal to 0. So the coefficients of the x and dy are both linear in the variables x and y. Let us pluck out the coefficients of the x and dy and let L1 be the line a1x plus b1y plus c1 equal to 0, and L2 or line L2 a2x plus b2y plus c2 equal to 0. Let these two lines L1 and L2 be such that they are intersecting, meaning to say the slope of L1 is different from the slope of L2, or A1 over B1 is not equal to A2 over B2. Why? If A1 over B1 is equal to A2 over B2, it follows that L1 and L2 are parallel. Okay? So we consider only the case wherein L1 and L2 are intersecting. So if two lines are intersecting, at most there is one point of intersection. So let HK be the point of intersection of L1 and L2. Let us make an illustration. Now let us indicate the point of intersection at H, K. Alright, so if we are to consider a point in the plane, that point has the coordinates x, y. We introduce a new set of coordinate axes. One that is parallel to x and the other that is parallel to y. Let us call this as u and v, right? U and v. With respect to the xy coordinate axis, the intersection is at hk, but with respect to the new set of coordinate axes u and v, the point of intersection is at 0, 0. Alright? Let us also express x and y in terms of the coordinates u and v. Clearly, your x here is equal to u. If we are going to project this point onto the new set of axes u and v, the coordinates of that point will be at u, v. And x is equal to h plus u, or u plus h. Similarly, our y is equal to the v coordinate plus k, v plus k. Now, with this, the equation of the lines L1 and L2 in terms of u and v will become a1u plus B1b equal to 0. And L2 is equal to A2u plus B2b equal to 0. With this translational axis, we can simplify the equations of lines L1 and L2 in terms of U and B with no pure constants appearing in the equation. Now, the equation of L1 in terms of U and B is free of the pure constant. In terms of x and y, the equation of line 1 contains the constant C1. The line L2 contains the pure constant C2. This constant C1 and C2 no longer appear in the equations of lines L1 and L2 in terms of the new variables U and V. This is exactly what we are going to use in solving our equation with linear coefficients. Again, since we are introducing new variables U and V, there will also be a change in the differentials. So taking the differential of x equal to u plus h and y equal to v plus k, we'll get dx equal to du and dv equal to, or rather dy is equal to dv. So we have to calculate for the point of intersection h comma k, and then we make these substitutions. And our equation will now transform into a1 u plus v1b du plus a sub 2u plus b sub 2v dv equal to 0. And this equation is homogeneous. Both coefficients are homogeneous of the same degree in u and v. And we know that an equation with homogeneous coefficients of the same degree has a solution. Okay, so let us have an example. We solve the equation x minus 4y minus 9 dx plus 4x plus y minus 2 dy equal to 0. So let us consider the coefficients of dx and dy and equate both of them to 0. Then we solve for the point of intersection. So we have equations 1 and 2. We can eliminate the y by multiplying 2. Multiply equation 2 by 4. So it becomes 16x plus 4y minus 8 equal to 0, and call it as equation 3. We then add equations 1 and 3. So x and 16x is 17x, negative 4y plus 4y is 0, negative 9, negative 8 is negative 17, equal to 0. That gives us the value of x equal to 1. So that is our h. Okay, so if x is equal to 1, we can substitute it to 1. So substitute value of x to equation 1 or to equation 2. So 1 minus 4x or 4y minus 9 equal to 0. So 1 minus 9 is negative 8. To the other side is positive 8. So y is negative 2. And that is our k. So the point of intersection HK is at 1, -2. Alright? So let x be equal to u plus h, or x equal to u plus 1. So dx is equal to du. And also y equal to b plus k, or y equal to v minus 2. So dy equal to dv. Okay? So we substitute this to our equation. What will happen? So x becomes u plus 1 minus 4 times y, which is b minus 2, minus 9 dx, plus 4x is u plus 1 plus y, which is b minus 2, minus 2 quantity dv equal to 0. Your dx becomes du, by the way. This will be du. Alright. So u plus 1 minus 4b plus 8 minus 9. Notice that the constants will vanish. Alright. Same thing here. We have 4u plus 4 plus b minus 2 minus 2. 4 minus 2 minus 2. So the equation simplifies to u minus 4b du plus 4u plus v dv equal to 0. So it will always be the case, no? X becomes u, y becomes b, dx is du, and dy is dv. The pure constants in the original equation, -9 and -2, vanish in the new equation involving u and b. So we are already assured that there is a solution to this differential equation because it is homogeneous of degree 1 in the variables u and b. Okay, so solving an equation having homogeneous coefficients with the same degree, we make another substitution, but since we have already used the letter v, let us say we use the variable c. So let c be equal to u all over v, or u is equal to v times c, and then the differential du equal to v dc plus c dv. Okay? So another transformation. Another transformation. So our u becomes v times c minus 4v du plus 4u or vc plus b d. By the way, sorry, our du will become, our du is vdc plus cdv. You see that? BDC plus CDB, that will replace du. And then plus 4u or VZ plus V dV equal to 0. Okay. So let us multiply. Let us multiply these two. B squared C minus 4b squared quantity dz, right? And then plus dv. bc times c is bc squared dv minus 4bc dv plus 4bc dv plus v quantity dv. So I think we can cancel negative 4bc. Okay, so 4b squared c minus 4b squared, we can factor b squared. That will be c minus 4 dc. Okay, and then plus, in the second term, we can factor v. So that will be c squared plus 1 dv equal to 0. And the variables now are separable. So we have c minus 4 over c squared plus 1 dc plus b dv over b squared equal to 0. The first term, we can separate this into 2. c over c squared plus 1 dc minus 4 over c squared plus 1 dc plus dv over v equal to 0. We proceed by integrating each term. c dc over c squared plus 1 is 1/2 ln of c squared plus 1 minus 4 dc over c squared plus 1. It is of the form a squared plus u squared, so arctangent of c over 1 plus ln of v equal to let me see, ln of c over 2. Okay, let me make it negative so that when I transpose it to the left, it becomes positive. Okay, so let me multiply everything first by 2. So it becomes ln of c squared plus 1 minus 8 arctangent of c plus 2 ln of v plus, I'm transposing it now, ln of c equal to 0. Okay, I can combine these 3 ln. So the ln of the sum is the same as the ln of the product. So that will be, let me see, c times b. The coefficient 2 becomes the exponent, so b squared times c squared plus 1 equal to, let me transpose this now to the right, so it becomes positive 8 arctangent of c. Okay, so what is my v? My b is, not yet, c first. What is my c? c is u over b. c is u all over b quantity squared, or u squared over b squared plus 1 equal to 8 arctangent of u all over b. ln of c, u squared over b squared plus 1 will become u squared plus b squared over b squared. But there is a v squared there, so that will cancel. Okay? So that will simplify to ln of c times u squared plus b squared equal to 8 arctangent of u all over b. That is not yet the final answer because we have to express u and b in terms of x and y. Alright? So I want some space here. So ln of c, my u is, here is my u, or this one. My u is x minus 1, x minus 1 squared, plus b is y plus 2 squared, equal to 8, arctangent of u, x minus 1 over b, y plus 2. So ln of c times x squared. Let me expand this. X squared plus y squared minus 2x plus 4y plus 1 plus 4, that will be plus 5, equal to 8, arctangent of x minus 1 over y plus 2. So that is our final answer. Of course, we have to write here the absolute value. There. So let us have another one. Okay. So let L1 be the line x plus 2y minus 5 equal to 0, and L2 the line 2x plus y minus 4 equal to 0. Call them as equations 1 and 2. Let us multiply equation 1 by negative 2 in order to eliminate x. No? So that will be negative 2x, negative 4y plus 10 equal to 0. So we now add equations 2 and 3. So x is eliminated, y minus 4y, that will be negative 3y. And negative 4 plus 10 is positive 6. So that makes y equal to 2. So if y is 2, x plus 2 times 2 minus 5 is 0. Our x is 4 minus 5 is negative 1 to the right, positive 1. Okay, so our h and k are 1 and 2. So let x be equal to u plus h, that will be u plus 1. And then y is equal to b plus k, where y is equal to b plus 2. Then we also have our dx equal to du and dy equal to dv. Okay, so let us apply this now to our equation. X will become u plus 1. And what will happen here? What will happen? This will transform into u plus 2v quantity du. No? Negative 5 will vanish. You just replace x and y by u and v respectively. No? So you can check that by replacing x by u plus 1 and y by v plus 2. No? And this is what you will get. Plus 2u plus v dv equal to 0. Okay, so we know that this is homogeneous, but it's possible that there are other available solutions or methods that we can apply. So let us see. This is u du plus 2v du plus 2u dv plus b dv. If I'm going to group these two, u du plus b du u dv, u du plus u dv plus b dv equal to 0. We recognize this as the exact differential of uv, right? So u du plus 2 dub plus b dv equal to 0. And the variables are already separated. So what we do is we just integrate. So u du is u squared over 2, and 2, the differential of ub, has the integral ub, plus b db, or v squared over 2, equal to c over 2. Multiply everything by 2. U squared plus 4ub plus b squared equal to c. Okay? Now, what is our u? Our u is x minus 1 and our b is y minus 2. So x minus 1 squared plus 4x minus 1 v y minus 2 plus y minus 2 squared equal to c. Okay? If you want, you can expand x squared minus 2x plus 1 plus 4xy minus 8x minus 4y. Okay, let me see. Xy minus 2x times 4 minus y times 4, positive 2 times 4, that will be 8, plus y squared minus 4y plus 4 equal to c. Okay, so we have x squared plus y squared, 2x, negative 2x, and negative 8x is negative 10x. Then, oh wait, I have to write 4xy first, plus 4xy. Okay, negative 2x and negative 8x is negative 10x. Then negative 4y is negative 8y. Then, what else? Sorry, there is a c here. It should not be 0. It is a constant. Okay, so 1, 8, and 4 will all combine into a single constant together with a constant c there. Let us call it a c1. And that is our final answer. Let's go to the third one. Okay, so y minus 2 is 0. That is our L1. And our L2 is x minus y minus 1 equal to 0. From the first equation, we already have the value of y equal to 2. Okay, so when y is 2, that will be x minus 2 minus 1 equal to 0. So your x is equal to 3. Y is 2 and x is 3. So our HK is 3 comma 2. Then let x be equal to u plus 3 and y equal to b plus 2. Then dx is equal to du and dy is equal to dv. So we know that this will transform into v du, without negative 2, minus u minus v dv equal to 0. Again, this is homogeneous, or an equation with homogeneous coefficients of the same degree. But there could be some other methods available in finding the solution. So let us see. b du minus u dv plus b dv equal to 0. Consider the first two terms, v du minus u dv. The integrating factor there is 1 over b squared. So let us multiply by 1 over b squared, or we divide by b squared. So v du minus u dv over b squared plus b dv over b squared equal to 0 over b squared, or 0. And see that this is the exact differential of u all over b, by or plus b dv over b squared is dv over b equal to 0. So we can just integrate. Thus we have u over b plus ln absolute value of b equal to, let's just say, c. So we multiply by v, u plus v ln of absolute value of v equal to cb. And what is our u? U is equal to x minus 3, while v is y minus 2. So x minus 3 plus y minus 2 ln of the absolute value of y minus 2 equal to c times y minus 2. Okay, so that is our answer. Next, you try working on x plus 2y minus 1 dx minus 2x plus y minus 5 dy equal to 0. Okay, try this number, or try this equation, and then we'll have the solution later.